At the A.P. Giannini Foundation, fellowship candidates look forward to the interview process as both an honor and an opportunity.
It was a huge honor, and going for the interview was such an interesting experience. I've never done anything like that before, and now that I've been through that, I wonder why more fellowships don't have these interviews, because I think it really gave me the opportunity to present my work in a way that's not doable when you just have to write it down. I think talking to someone about it just made it that much clearer. Finding out that I had actually received this fellowship was incredible, because it meant, first of all, it meant that the foundation thought that what I was interested in doing and what I wanted to do was going to be important and useful in the medical field. And that's a huge validation, because that's what we're here for. I have my own funding to conduct my own project, and it means that I'm able to do something that will advance my career independently, which is just excellent. What we call stem cell research is just very basic molecular biology applied to stem cells as it would be to any other cell type. The field that our lab is interested in, Dr. Blalock's lab, and of course that I'm interested in, is the field of early development. We think it's very important to understand early development in order to be able to obtain these very important stem cells in ways that don't have any ethical implications. Early embryonic research is going to be very, very important in the very near future, where we're sort of getting into this phase where people are saying, oh, you know, we can make specialized organs for specialized patients. I mean, obviously we're far away from that, but just that thought is so enticing, and I think that we are on the sort of verge of entering that arena of being able to really go ahead in reproductive medicine and do things that even 10 years ago we would have thought were completely impossible. When people first said that you can take adult cells and make them into embryonic stem cells, I just remember the feeling that went through, I mean, not just my lab, but you know, the entire department, the entire field. Everyone was just so excited. These are personalized cells that come straight from you back to you. I would love to think that 10, 20 years from now, you know, if you or I had the need for, you know, a kidney or a part of a liver or something, we could just go in and, you know, scrape some cheek cells, and a couple of months later, someone could, you know, have grown a kidney in the lab, and we could just get a transplant. You know, that's me being optimistic. Obviously, that's not going to happen in 10, 20 years. But if we can even have a system by which we can have even personalized blood transfusions, let's say, as a more basic way of starting out, I think that it would revolutionize medicine. I almost can't even imagine the repercussions. I mean, I feel like we would be able to treat and cure diseases at a new level that we never have been able to before. And you know, I really hope that you know, I'm around in the field, in science, long enough to be able to experience that happening. And so I think that's one of the main reasons that drives me and probably a lot of people to stay in science, because we have these dreams of how things are going to turn out, and you want to be in the thick of it when it happens.
And to learn more about the support a fellowship provides, please visit apgianninifoundation.org.